On the 21st and 22nd of August 2005, Zurich only narrowly avoided major flood damage. After heavy rain, the river Sihl rose to the top of its banks. Luckily, there was no notable flooding here. In the last 30 years, extreme weather conditions and floods have been noticeably frequent in Switzerland, probably due to climate change. As weather events become more numerous and intense, the probability of extreme floods also rises. Zurich is also at risk, as large areas of the city are located on the river Sihl's alluvial fan, a natural flood zone. The area has always been subject to flooding. In the storm of 2005, Zurich was simply lucky. If that storm's precipitation had been centered over the river Sihl's catchment area, computer simulations show that large areas of central Zurich would have been flooded, including the main railway station. In an area of around 5 square kilometers, tunnels, shopping arcades, and thousands of basements would have been underwater. The building's insurance department estimates the potential damage at up to 6.7 billion francs, and the failure of communication and transport networks would entail further losses. In view of the continuously increasing risk of damage and the fact that the risk of flooding is likely to grow as a result of climate change, the canton of Zurich set out implementing an extensive set of measures after narrowly escaping flooding in 2005. In order to minimize the risk in the short term, the flow capacity of the culverts below Zurich's main railway station, a highly critical point, was increased in 2007 by lowering the riverbed. In addition, the WWEA, the Cantonal Office of Wastewater, Energy and Air, has been reassessing the situation on a daily basis since 2005, using water body measurements and weather forecasts. This means that prior to an imminent heavy rainstorm, the river Sihl's maximum flow rate can be used to start lowering Lake Sihl's water level. This measure has to be started 4 days in advance, however. When the flood event actually sets in, the lake is refilled by the flood wave that would otherwise have flowed into the valley. From 2018, the advanced lowering of Lake Sihl will be optimized by means of an automatic control system. This system releases as much water from the lake as possible as required. If, however, flood peaks occur on the rivers Alp and Biber at the same time, usually of short duration, the lake discharge is automatically reduced based on measuring data. This allows optimum utilization of the Sihl's discharge capacity before and during the flood event without the risk of flood damage below the confluence due to overlapping flood waves. Thanks to these measures, good use is made of the Sihl's existing discharge capacity, reducing the risk of flooding significantly. There was nevertheless another problem that would have made all the measures on the Sihl futile: blockages due to driftwood, or so-called debris jams. Rising water collects deadwood in the riverbed on the nearby riverbank. Due to erosion or landslides caused by the flood and heavy rain, a number of trees can also end up in the rivers. Consequently, blockages of bottlenecks, such as bridge arches, constantly lead to rising water levels and thus to flooding. Furthermore, the Sihl's catchment area lies in an often steep wooded area, which can be the source of large volumes of driftwood during flood events. In 2009, the canton of Zurich conducted an extensive study of driftwood. The conclusion was that around 12,000 cubic meters of driftwood could be expected outside Zurich in the event of extreme floods. In comparison, 2,000 cubic meters of driftwood accumulated on the river Zurich in the canton of Bern in 2012. 6 times this volume could be expected in the event of extreme floods on the Sihl. Such huge quantities of driftwood could lead to blockages at critical points in the city of Zurich, such as the SZU railway bridges, the Sihl Hochstrasse, and more particularly the main railway station, which would cause flooding and massive damage. The retention of large quantities of driftwood in the Sihl culverts under the station was thus examined by the Laboratory of Hydraulics, Hydrology and Glaciology at ResO Zurich. To this end, the experts at the ResO simulated different flood incidents in a complex model experiment. In addition to the Sihl culverts, all the parameters such as the surrounding areas, water volumes and the sizes of debris and driftwood were precisely reproduced on a scale of 1 to 40. Through a series of tests, the researchers came to an alarming conclusion. The volume of driftwood predicted in the study could almost completely block one or more of the Sihl culverts. Such a scenario during a period of extreme floods, which the unimpeded culverts would only just manage to handle, would dam the Sihl right in front of the station. The consequences would be massive flooding in the city centre. As a result, the canton of Zurich took the decision to build a driftwood rack in the Sihl. Following an extensive review of possible locations, it was decided to build the so-called parallel rack in the Rütiborden River section near Langnau am Albis, above a possible flood diversion tunnel. The course of the river was shifted and the curvature of the bend exaggerated. The actual retention space, about the size of a football pitch, was created parallel to the river. The retention utilizes the effect of the river bend. At the bend, the centrifugal force pushes the surface water outwards. The water begins to revolve. A second current forms perpendicular to the main current. In combination with the flowing motion, the water begins to spiral. The surface water transports driftwood to the outside of the bend. If the water level rises, the wood, which becomes more frequent during floods, enters the driftwood retention basin. The sediment transport is carried along the river bed and doesn't reach the retention basin. A training wall in the upstream part of the rack stops water flowing back into the Sihl prematurely. This causes the wood to gather in a compact manner at the 3 to 4 meter high columns at the end of the rack. The actual course of the river is never obstructed. No parallel rack of this size has ever been built before. As with the Sihl culverts, the functionality of the system was therefore checked at the ResO Zurich. The retention space stays dry in normal water conditions. The barrier design causes the Sihl to start flooding the retention basin at an annual peak water level. However, only when a 10-year peak and thus a critical water level is reached does enough water flow over the barrier to cause driftwood to reach the rack. Consequently, the rack rarely needs to be cleared. The model experiments at ResO Zurich enabled the structure's geometry to be optimized. The experiments showed that the system works as planned. The rack will safely retain up to 95% of the driftwood in the Sihl. So after 15 years of planning, studies and project development, construction on the rack could finally begin in April 2016. Some 200,000 cubic meters of earth were moved to build the rack. First, the banks of the inner bend were excavated, the river bend was exaggerated, and the new river bed was created. At times, up to 20 heavy construction machines were used to build the rack in the area of the former course of the river. The foundations for the columns are massive and designed as such that even when full, the rack safely withstands the water pressure resulting from any level of flooding. Wherever possible, natural stone was used as the consolidated surface. In April 2017, the rack was almost complete. The final work on the banks was being carried out on the inflow barrier. The new course of the river was made as natural as possible. The retention space was amply dimensioned and certainly sufficient to contain the predicted maximum volume of 12,000 cubic meters of driftwood. In May 2017, the final columns were inserted and aligned. After 1 year of construction at a cost of 18 million Swiss francs, the driftwood rack was operational. In conjunction with other short and medium-term measures, the driftwood rack significantly reduces the risk of flooding in Zurich. If, however, in the event of prolonged and extreme rainfall throughout the entire catchment area of the Sihl, Zurich is still not sufficiently protected against the catastrophic flooding that would ensue. It was clear to the authorities that in such an extreme case, the flow rate of the Sihl would have to be reduced even further. In 2017, after examining the different solutions, the Zurich State Council decided to build a flood diversion tunnel directly below the driftwood rack. The tunnel can divert flood waves on the Sihl to Lake Zurich, thereby protecting the lower Sihl Valley and the city of Zurich against extreme flooding. The tunnel inlet is thus protected against driftwood by the rack. The flood diversion tunnel could be completed by 2023. With the tunnel, the driftwood rack and the other measures, Zurich would also enjoy the best possible protection against catastrophic flood events on the Sihl.